Hello, welcome to the Argo course. My name is Mohammad and I'm very happy to be here. In this session, I want to talk about two different topics. The first one is about adding a new Kubernetes cluster to Argo CD, and the second one is about tracking and deployment strategies in Argo CD. Let's start with adding a new cluster. Very good. First of all, I want to show you something. If I type Argo CD cluster list, Argo CD, Argo CD cluster list, you can see that we have only one cluster in our Argo CD environment, and this is our local cluster. Because of that, if we deploy our applications, these applications will be deployed in this cluster, in this local cluster. You can see this result in dashboard UI 2. If I click on settings and clusters, you can see that we have only one cluster, and this is the local cluster that Argo CD is using for deploying the applications. But I want to add a new cluster to this environment. But how can we do? I have prepared a new machine and I want to use this new machine as our new Kubernetes cluster. I'm using kind in this machine to do some tasks to add this cluster to our Argo CD environment as our new Kubernetes cluster. Very good. The first step of adding a new Kubernetes cluster to Argo CD is creating a service account. The service account is responsible for deploying the applications in this cluster. So it must have the necessary access into this cluster. It can be an admin in this cluster, for example. Because of that, first of all, I want to create a new service account here. I type kubectl create as a new clusters a. And if I type kubectl get SA, as you can see, we have a new service account called new clusters a. I want to bind the cluster role of cluster admin to the service account, because it must have the necessary access to this cluster. If I type kubectl get cluster role cluster admin, we have a cluster role called cluster admin. So I want to bind this cluster role to our new service account. Because of that, I type kubectl create cluster role binding --help. I want to use this example. Okay. Instead of user, I want to use service account equals the namespace of our new service account is default, and the name of the name of the new service account is new clusters a. The cluster role name is cluster admin, and what about cluster role binding? I want to change the name to Argo CD binding. Very good. or it already exists, Argo CD cluster binding. Very good. And we are going to bind this cluster role, cluster admin, to this service account, new cluster. So this service account is an admin in this cluster. To prove that, I want to type kubectl as can I, for example, create pods -- as system service count default new cluster, say. What is the name of the namespace? New cluster, say. Yes. It can create pods, delete pods, and for example, delete deployments. And yes, this service account is now an admin in this cluster. Very good. As you know, in the new versions of Kubernetes, there is a change that doesn't auto-create the secret when you are creating the service account. Because of that, if you want to have a new token for your service account, you have to create it manually. I want to generate a token for our service account. Because of that, I type kubectl create token for this service account. Very good. So we created a service account. We binded cluster admin cluster role to this service account. So it is an admin in this environment. And finally, we generated a new token for this service account. What is the next task? I want to show you something. This is our Git repository files and folders. We have a new directory here called Argo CD add cluster. A subdirectory called add cluster. Another subdirectory called add cluster using manifest. And we have a file. This is a manifest, and its kind is secret. We have to apply this manifest in our Argo CD environment. This environment. This is our local cluster environment. So we have to apply this manifest here. Its kind is secret. Its name is external, for example. Its label is important. This manifest is using a label called Argo CD argo-proj.io/secret type equals cluster. It means that this is a secret with type of cluster. The string data, we have multiple fields here. We have multiple key value pairs. The first key in the first field is name. You can change this name whatever you want. It doesn't matter. What is the name? If I type Argo CD cluster list, as you can see, we have a local cluster, Kubernetes the default .svc, and its name is in cluster. We can deploy our applications into this cluster using this name. So the name of the new cluster will be changed to this name. You can change it whatever you want. The second one is server. This is the API server address of our new cluster. If you see the kubeconfig of our new Kubernetes cluster, I type vi kubeconfig. This is the server address of our new Kubernetes cluster. You have to use this value instead of this. And the last field is config. The first one is bearer token. We created a token, and this token is now an admin. And in the files tab, we generated a token for this service account, this token. You have to use this generated token instead of this value here, service account token. So if you create your service account, if you bind your service account to a cluster role, and if you create a token for your service account, you have to replace the token here. The TLS client config, our connection is secure, so in insecure it equals false. And the CA data, the ca.crt, the certificate of our new Kubernetes cluster. I already grabbed the certificate of this cluster. This is, if I open this file, this is the certificate of our new Kubernetes cluster. But first of all, we have to convert this content into base64 encoded certificate. Because of that, let's cat this file and pipe it to base64, and then pipe it to tr-d/n. You have to convert this certificate into base64 encoded certificate, and then copy the content and paste it here. Let's do that. I copied a secret. I type Argo CD secret.yaml or cluster secret. Cluster-secret. I paste the content here. The name of the secret is external is good. The name of the new cluster is external. Let's change it to DevOps-hobbies, for example. What is the API server address? If I go to kubeconfig file, kubeconfig, you can use this server address here. Yes. But what is the bearer token? The bearer token is the generated token for our service account. This is the new generated token for new cluster as a service account. And I copy the content and paste it here instead of this value. And base64 encoded certificate. So I copy this base64 encoded certificate and paste it here. And yes, that's it. Let's save the file and apply it. kubectl apply-f secret, but before applying this secret, I want to show you something. Let's type this command again. And as you can see, we have only one Kubernetes cluster. But if I type kubectl apply-f cluster-secret, and the secret has been created, and if I type Argo CD cluster list again, you can see that the new cluster has been added to our Argo CD environment. Its status is unknown, but don't worry about this status. It's because we have not yet deployed an application on it. If we deploy the first application into this cluster, its status will be changed from unknown to successful. So don't worry. And if I refresh this page, the new cluster has been added to our Argo CD environment. Okay. Let's deploy the new application, but in this time, I want to deploy the new application into this new cluster. We have a file called app-2. Its name is external. Let's change the name to new cluster application. The namespace is external. It's good. The name. This is the name of our new Kubernetes cluster. What is that? It's here. This is the name of our new Kubernetes cluster. I copy the name. The name is DevOps-Havis and paste it here instead of external. Very good. And we are using sync options equals create namespace. It means that if this namespace is not exist in the new cluster, Argo CD will create this namespace first and then deploy the application. Very good. So our application will be deployed in the new Kubernetes cluster. Let's save the file and apply it. kubectl apply-f app-2.yaml. Let's go to Argo CD dashboard UI. Its status is out of sync. You can use auto-sync sync policy to sync this application automatically, but I didn't use it. Let's click on sync and click on synchronize. And yes, our application has been synced, and the last sync is sync OK. Let's go to our new cluster. If I type kubectl get all -n external. Yes, these are the resources that we deployed into this new Kubernetes cluster. As we said earlier, its status was unknown, but we deployed the first application into this cluster. So what is the status of this cluster now? If I click on clusters, you can see the status has been changed to successful. I can prove that here too. Argo CD cluster list, you can see that status has been changed to successful. Very good. And this time, I want to use Terraform to do all these tasks. We created service account manually. We binded cluster role admin to our service account manually. We generated the token and we applied the secret manually. But in this time, let's do all these tasks using Terraform. Very good. Let's go to our Git repository files and folders here. Okay. Argo CD add cluster, and we have a new subdirectory called add cluster using terraform. I already prepared all these files to show you how can we add the new cluster to Argo CD environment using terraform. Very good. The first file that I want to show you is providers.tf. In this scenario, I want to create Argo CD resources and Kubernetes resources. Because of that, I'm using all these providers. I'm using Argo CD and Kubernetes providers. So I need both of them, Kubernetes and Argo CD. In Kubernetes provider, we are using config path and config context. Terraform wants to know where can we deploy the resources? Where can we create the resources? The config path is this, terraform.tf vars. Config path is kubeconf, the kubeconfig. And the context that I want Terraform to use it is this, new cluster context. This is the context of the new cluster. If I go to the kubeconfig of Argo CD environment, if you can see, there are two different clusters in kubeconfig. This is the local Kubernetes cluster, and this is the new Kubernetes cluster that I added already. The server address, this is the server address of our new cluster. It's CA and its name. And we are using a new service account called new cluster user, and its context is this, new cluster user and the name of the context. So we are using this context, new cluster context. So Terraform connect to this context to deploy and to create the resources. And its API server address is this machine. Host name -i, and as we can see, this is the IP address of this machine. Okay, and in Argo CD provider, we are using the server address, username, and password, and we are providing these informations in terraform.tf vars. This is the server address, localhost, and this is the port, username, password, and connection method is insecure. So this is the machine. So we are using Argo CD provider to deploy and to create the resources into this environment, the local Kubernetes cluster, Argo CD environment. And we are using Kubernetes to use the config context, to use this context, new cluster context, to connect to this new cluster and create the resources in this cluster. Very good. And we are using an alias for Argo CD provider. Argo CD underline server is the alias of Argo CD provider. Very good. Let's go to main.tf. The first resource that I want to create using Terraform is this Kubernetes service account. The resource type is Kubernetes service account, and the resource name is Argo CD manager _SA. The name of the Kubernetes service account that Terraform wants to create is this. Argo CD Manager SA. This is the name of the service account that will be created in the new Kubernetes cluster. And its namespace is default. The second resource is Kubernetes secret. And the resource name is Argo CD Manager secret. I want to create this resource, I want to create this secret because I need the token for our service account. Because of that, we are creating this secret to have a token for our service account. The third resource is Kubernetes cluster role binding. We are using this resource to bind the service account to a cluster role called cluster admin. The reference of the service account is this. This is the reference to the name of this service account here as the first resource. And this is the reference to the namespace of the service account that we created earlier here. So we are binding this service account to a cluster role called cluster admin. In the next block, we have a data block. Data block, what is data block in Terraform? If we want to retrieve and if we want to gather any information about an external resource, we use data. For example, we create a Kubernetes secret. So this secret has multiple attributes. For example, C8 and tokens. So we are using data to gather any attributes related to Kubernetes secret, for example. Because of that, data is helping us to do that. And the last resource that I want to create is Argo CD underlying cluster. This is a resource related to Argo CD. I want Terraform to deploy and to create this resource in local Kubernetes environment here. I want Terraform to deploy this resource here in Argo CD environment in local Kubernetes cluster, not in Neo cluster. Because of that, I'm using provider equals argocd.argocd underlying server. Argo CD is the name of the provider and Argo CD underlying server is the alias of this provider. So it means that I want Terraform to deploy this resource in localhost. Okay? In this resource is a secret. As we saw earlier, we created a secret into Argo CD environment called cluster secret. It was the secret that we created in the previous section. We created the secret in Argo CD local environment. So we are using this resource to create this secret in Argo CD environment. It has multiple fields. For example, server. This is the name of this. This is the server address. What is the server address? New cluster server address. If I go to terraform.tf vars, new cluster server address is this. Okay? And we have a different block called config. What is bearer token? This is the generated token for the service account that we created here. This is the service account that Terraform created, Argo CD Manager SA. And we created a secret to have a new token for your service account. And we are using the token here in bearer token. And we are using ca.crt here. In Terraform, we have multiple built-in functions, and one of these functions is lookup. Lookup takes two arguments. The first argument is a map. A map means multiple key value pairs. The first argument is a map, and the second argument is a key in this map. In this example, we are using lookup to return the value of a key called token from this map. And in CA underline data, we are using lookup to return the value of ca.crt key from this map. Very good. Let's apply this Terraform file. I already downloaded any necessary plugins to use Kubernetes and Argo CD providers, but if you are using this Terraform file for the first time, you have to type Terraform init to download any necessary plugins. We use Terraform FMT to format any necessary files or changes. Very good. I tried Terraform play. As you can see, 4 different resources are ready to add. The first resource is Kubernetes service account called Argo CD Manager SA, and its name is Argo CD Manager-SA. Its namespace is default. This service account will be created in this environment. And we are creating a secret to have a token for our service account. And we are binding our service account to a cluster role called cluster-admin. And we are using Argo CD cluster, new cluster resource, to add the Kubernetes cluster to Argo CD environment. Very good. Let's type Terraform apply. Enter a value. Yes. What is the problem? Already exists. Cluster with server addresses already exist. Oh yes, I forgot to remove the previous cluster that we created. Yes. First, let's destroy all the resources. Okay. First of all, let's delete this application that we created in the previous section. One error, unauthorized. The application is deleting. Let's go to clusters and let's delete this cluster. Very good. Okay. Let's apply this Terraform file again. Enter a value, yes. And as you can see, 4 different resources added. 3 resources added to the new cluster here. If I type kubectl get SA, you have seen that we have a new service account called Argo CD manager underline SA. And we have a secret, get secret called Argo CD manager secret, and it has 3 different fields in its data block. That one of them is token for this service account. And if I go to Argo CD cluster list, as you can see that this resource has been created using terraform and its status is unknown because we have not deployed any applications on it. Okay, its name is the same with server address. You can use the name here. I forgot to use that. We used server, but we can use the name too if you want to have a different name. We didn't provide any names because of that. The server value and the name value are the same. Very good. I copy the name. Let's go to app-2 app-2.yaml. Let's copy from this cp app-2 to app-3. New cluster application using terraform. The namespace is terraform, for example, and the name of the cluster is this. Very good. Let's apply it. kubectl apply-f app-3.yaml, and the application has been created. The status of the application is out of sync, and the status is successful. If I click on synchronize, these resources have been created in terraform namespace in the new cluster. If I go to the new cluster and type kubectl get all -n terraform, you can see that all these resources have been deployed and have been created in terraform namespace in the new Kubernetes cluster environment. Okay, we deployed and we added the new Kubernetes cluster using terraform, and we did all these tasks automatically using terraform. Very good. In this time, I want to talk about tracking and deployment strategies in Argo CD. An Argo CD application spec provides several different ways of tracking Kubernetes resource manifests. Let's go to VS Code. We have a new directory in Argo CD cluster, a subdirectory called tracking strategies. And we have 2 different files, git.yaml and helm.yaml. Let's start with Helm. This is an application that's using a Helm repository as its source. This is the repo URL. This is a Helm repository, and we are using this repository, and we want to use sealed secrets chart from this repository as the source of this application. But let's attention to target revision. If we are using Helm application, the target revision is different with Git. Let's go to the note. If we are using an application and this application is using a Helm repository as its source, its target revision is different. The target revision can be a specific version. For example, I want to use the version of 1.16.1 of this chart, seal the secrets, from this repository. I want to use this version of this chart from this repository. So we are using a specific version called, for example, 1.16.1, a specific chart version. Or we can use a range. Use a range. We are not going to use a specific version. We can use a range. For example, I want to use a range like 1 point star. But what it means? 1 point star equals this pattern. Greater than or equal 1.0.0, smaller 2.0.0. These are the same. Or we can use a different pattern. For example, I want to use 1.2 point star. It is equals this pattern, greater than equals 1.2.0 and smaller 1.3.0. These are the same. So we are using a range as the version of the Helm chart in this application. This is a range. Or we can use the latest version of a chart. I want to use the latest version of a chart from a Helm repository. Latest version. Because of that, we can use this pattern, star. Star means the latest. Okay? It was about Helm. So if we are using an application and its source is a Helm repository, its target revision can be one of these choices. But what about Git? If we are using an application that its source is the Git repository, what are the choices? I type Git. The first choice is using a symbolic reference like head or using a branch name, for example, main. If a branch name or a symbolic reference is specified, Argo CD will continually compare live state against the resource manifest defined at the tip of the specified branch or the resolved commit of the symbolic reference. To redeploy an application, make a change to one of your manifests, commit and push to the track branch or symbolic reference. Then the change will then be detected by Argo CD. So the symbolic reference is pointing to the latest commit. And we can use a branch name too. The second choice is using a tag. We can use a tag. For example, I want to use a tag called Vivan. If a tag is specified, the manifest at the specified git tag will be used to perform the sync comparison. This provides some advantages over branch tracking, and that a tag is generally considered more stable. To redeploy an application, the user uses Git to change the manifest of a tag by retagging it to a different commit SHA. Argo CD will detect the new meaning of the tag when performing the comparison sync. And the last choice is using a commit. If the commit SHA is specified, the app is effectively pinned to the manifest defined at the specified commit. This is the most restrictive of the techniques and is typically used to control production environments. Very good. It was about target revision. These are the choices that we have in an application that is using Helm as its source. And these are the choices that we have in Git, an application that is using Git as its source. So these are the choices that we have. Very good. Thank you very much. That's enough for this session, and I will see you soon.